Section 9.2, ANOVA for regression, video 2. So if we're doing an analysis of variance on a linear regression, where is this variability that we're analyzing? Well, let's go back and remind ourselves what a population regression model looks like. At the population level, our simple regression is y representing the response variable equals beta 0, your intercept, plus beta 1, your slope, times x, your explanatory variable, plus an error term, which we call epsilon, lowercase epsilon. The error term accounts for the variability in y, the variability in your response variable that is not accounted for by the equation itself. Maybe there are other factors in play that this equation doesn't represent. For example, if this represents a tip amount that we're predicting based on the bill at a restaurant, what else could affect the tip amount besides the bill? Could it be the number of people in a party? Could it be the quality of the food? Could it be the quality of the service? None of those things are accounted for by just saying the bill amount. And so this error term generically represents everything that we're not accounting for over here. So how do we do analysis of variance on this? When we did analysis of variance previously, when we talked about variability between groups and variability within groups, when testing if population means were equal, we were looking for the reasons why they were different. Was it because of variability between groups, meaning that the groups were positioned differently in terms of their means? Or was it variability within groups, meaning that some groups were thinner than other because of smaller variability? The breakdown of variability here can be seen in two places on the right and one place on the left. What we're attempting to explain is variability in the response variable. But on the right side, we can look at two places for variability. We can look at variability explained by the model, variability explained by the model. And when I say the model, I mean the linear regression, the equation, this part. But this error term would represent unexplained variability. One second. In the error. Meaning the things that we're not accounting for could account for some of the variability in our response variable. Sneeze coming on. I promise you, it's allergies, not coronavirus. And so if we're going to test the effectiveness of a model, we're basically asking, where's the bulk of the variability over here? Is it within the model or is it within the error? And when we did analysis of variance previously, you remember when we calculated an F statistic as MSE over that's backwards. MSG over MSE. Let me double check to make sure I don't have it backwards now. Okay, it's correct now. We were comparing the amount of variability that was in the model or in the groups compared to the variability in the error. And we were looking at that ratio to make a conclusion about whether or not the model was effective. Previously about whether or not the means were equal. And we're going to be doing the same thing here. So we're going to see an ANOVA table that's going to look almost exactly like the one we did before, with a couple of minor changes.